Okay, John, it's been a few months since we last did one of these. Can you tell us what's been happening since last we met?
Right, well, yes, we've been mainly working on the boiler, which, as you can see over here, has progressed quite considerably since the last video. Most of the major components are now together. The firebox is in, the dome's on, the front tube plate's on. So there's a lot of progress in the boiler area. We've also done some work on the tender and some more work on the mechanical side. Obviously we've got the boiler sat on its rollers here, which enables Bob, who's doing most of the boiler building work, to rotate the boiler to work on it at different angles. So it's sat on its side here, obviously. You can see we've got the dome, which mainly you won't see on the finished loco because it's hidden by the saddle tank. But here's the dome, which collects the steam, and in here you can see we've got the regulator valve, which is an original component from the old boiler that we've refurbished for reuse. That's a cast iron piece. It had to go away and have some specialist cast iron welding done on it to bring back some wasted areas. Anyway, that's now installed, ready. Yeah, so you can see here the cast iron face of the regulator valve. When it's together, there will be a valve sitting on here that moves up and down under the control of the driver and opens these ports to steam from the boiler space. It goes down inside the regulator J pipe and then out the main steam pipe to the front and down to the cylinders. Okay, so here we've got the front tube plate, which is quite a thick piece of plate, as you can see, and it's been riveted in position. Here's the rivet heads onto the angle and the boiler barrel. Because this is a hybrid boiler construction, we've got part riveting in the traditional manner like the old boiler, but part of its construction is welded, as you can see here. This ring here that's attached, which is where the smoke box goes, that's been welded on. We use different forms of construction basically because some places are more suitable for rivets, some places are more suitable for welding, so we've got a hybrid construction. You can see here all the holes for the tubes, where they will go. There's a tube just sat in here at the moment. This tube pattern is a copy of the original layout, so the steaming of this boiler is going to be pretty much like as the original boiler was. Up here you can see these big nuts on threaded bars. These are long stays which go all the way back to the other end of the boiler, and they tie these flat pieces of plate area together to stop it bulging, basically. Here, this is where the main steam pipe from the regulator exits. So on here there'll be a big elbow and a pipe will go down inside the smoke box to feed the cylinders. Okay, so here we're looking in the top of the outer firebox to the top of the inner firebox, and what you can see in here is these big things, they're called the girder bars. They actually stiffen the top of the inner firebox because that's a flat plate, so it needs some considerable stiffening to resist the steam pressure. This circular bars you can see here and here, they are the long stays that we saw the other end of at the front tube plate. Okay, so here we are at the back of the boiler. You can see the other end of those long stays here. There they are. These pads here and here, they're where the water gauge fittings will go. We've got Nice new shiny water gauge fittings here, as you can see. They're ready to be mounted on. This is where the regulator handle will emerge. There's a sealing gland arrangement, and then the regulator rod will come out here. Down here, of course, you've got the fire hole ring. You can see that's welded in. And we've got all these little holes that are dotted about all over the firebox. These are where the stays will go, which are threaded bars, which will be screwed through the outer firebox here, through the water space, and screwed into the inner firebox as well. So they'll tie the inner and outer fireboxes together to resist the steam pressure, because obviously this is a big flat space, and with the steam pressure pushing it out from inside, this would bulge without these stays tying it to the inner firebox. Curved parts of the boiler, they're capable of resisting the steam pressure without any stays, so that's why there's no stays around the curve. Up here we've got this is a washout plug boss, which as you can see, that's been welded onto the curve, and there's a nice new thread in here. There'll be a bronze plug screwed into here. That's a washout plug. Basically that allows us to, when the loco needs a washout, we unscrew the plug, let all the water out, and wash in here round the sides of the firebox to get out any scale and mud build-up, which is important in boiler maintenance.
How often roughly would you have to do that?
Depends on how you use it and how good the water is. We're lucky on the FR, the water supply is pretty good, and we treat the water. So we usually only need to actually wash out an engine every few months. Some railways that don't have such good water supplies, have very hard, scaly water, they need to wash out perhaps every month. Just depends. Here we are at the bottom of the boiler, if you like. This big, thick ring here, this is called the foundation ring, and at the bottom it's tying the inner firebox plates and the outer firebox plates together, held by the rivets that are going to go through these holes, and they'll tie all that together. They'll tie the inner and the outer to the foundation ring, which makes a solid bottom part to the firebox assembly. If you look up inside the firebox, you can see this is the firebox tube plate. So here are all the holes for the tubes again. Fitting the tubes is one of the last jobs to do on assembling the boiler. You can see the holes for stays here, which will go through again to the outside. If you look up at the top, you can see a series of bolt heads. Those bolts go up into the girder bars that we mentioned earlier, and stiffen that flat top of the firebox. And yeah, these little threaded stays here that are going in at the moment, these are called palm stays, and they tie this tube plate to the boiler barrel. Here we're looking at the underneath of the boiler. This boiler barrel bottom. Obviously this is a new part we've bought in, rolled and welded. There's just a single welded seam. You can't see it's round here at the moment, but that's produced outside by Deepdale Engineering, who do basically made up most of the kit of parts for this new boiler. The old boiler would have had riveted seams all down it and was done in 3 parts. So this is a much simpler form of construction, and you know, nobody's going to see this finished item. It's not going to make any difference to the performance. So having a welded barrel makes a lot of sense from a construction point of view. You can see here here's the weld where the barrel is attached to the throat plate of the boiler. This is the throat plate. It's got this nice curved part. This plate was made for us by Israel Newtons in the Peak District, because they've got specialist gear for making this kind of curved plate. So we've assembled this, and then you can see more of the stay holes ready for the stays to go in, which will tie this plate to the inner firebox inside.
Okay, John, so when this is ready to be fitted, how is it actually secured to the frames?
Okay, so what we're going to have is brackets fabricated. They'll go onto the front of the firebox here and here, pointing forwards to the front of the loco. And then these brackets will be bolted to the back of the frames with bolts running this way. So the frames will run then forward underneath the boiler. And you can see these two slots are where the back of the smoke box, which this plate forms, as well as the front tube plate of the boiler. The frames will slot in here and run on to the front of the loco.
Okay, John, what have we got here?
Okay, so we've got new crank pins for Welsh Pony here. Leading ones, shorter ones, we see little collars to keep the rods on, and these are the driving crank pins here. These we've machined, and they've been sent away and been hardened by a nitrogen process. So, which we've found over the past few years works very well. It makes them extremely wear resistant, which is the problem with crank pins. That's why we're changing them. The old crank pins were quite worn, and an engine with worn crank pins is very hard to get to run smoothly without clanking. So new crank pins is definitely worthwhile. You can see some of the bits of marked up green. Those are areas that are masked for that stops the hardening process, which will allow us to do a final machining in this area where the fit is going to be into the wheel. Now this pin here, just for a way of comparison, this is a new Garrett one for Garrett number 130, just to give you a size comparison. So we actually fit these by shrinking the pin with liquid nitrogen, because the hole in the wheel is machined slightly smaller than this pin diameter here. So we shrink this with liquid nitrogen, push the pin into place, and then as the temperature of the pin comes back up to ambient, it will grip in the hole, and that's what locates the pin.
And how would they have done that in the old days when they didn't have liquid nitrogen?
Right, well back then they would have used a press and probably machined a small taper on here, and they would have been assembled by a force fit, which works okay, but liquid nitrogen it's a lot easier, and it puts a lot less stress on the wheels, and particularly where we've got old wheel centres like Welsh Ponies, we don't want to risk damaging them. So liquid nitrogen shrinking is the way to go for that. Okay, so here we've got we've got the leading wheel set from Welsh Pony. It's up on the horizontal boring machine we've got, and the centres in the end of the axle have been recut to the 60-degree standard we use now, which just makes life easier for remachining the wheels when we need to. And you can see the old crank pin here. It's actually had a hole bored right through the middle of it, and this old crank pin, because it was worn, we're going to take that right out and machine the hole for the new pin to be fitted. We need this boring machine to do this job because the two pins need to be exactly at 90 degrees to each other for the loco to run smoothly. So this machine, because it's very accurate and indexes either up or down horizontally very precisely, we know that we can cut the holes for the crank pins exactly at 90 degrees to each other and exactly the right distance, so that the pins are going to be in the right place and the loco is going to run smoothly. Okay, so here we've got some new bronze castings ready for Welsh Pony. They're sat here by the machine waiting machining. We've got new axle box castings here ready to go, because the old axle boxes we found they were beyond repair. This nice curvy item is from an original pattern we found. That's the whistle manifold, which will sit on top of the saddle tank, and the two whistles will be mounted there. Down here we've got the gland and the quadrant for the regulator that will sit on the back head of the boiler. Then on top of the firebox of the boiler will sit this bronze turret assembly, which has various take-off points for valves, for injectors and so on. And also in the top of it is this safety valve, because we're going to use the original pattern of Salter safety valve here. There'll be a second modern safety valve hidden on top of the dome, underneath the dome cover, so you won't see that. And then also these nice curvy bits here go in the cab above the safety valve and take the steam out of the top of the cab.
So this is components for the tender, is that right, John?
That's right, yes. The tender chassis is now pretty much all together. You can see the axle boxes and springs here, ready for the wheel sets to be fitted. The chassis is all assembled, and here we've got the side plates and some more side plates over there. These are just being painted up, ready for riveting the body together, so it won't be long before the tender's assembled. You can see here the rear coupling. This is the modern FR chopper coupling is fitted there, but there's also an alternative heritage style buffer with, and there'll be a link coupling to go with that. You can see that there. So the two are interchangeable, so we can either choose to work with chopper couplings, say on the Welsh Highland with a passenger train, or on the FR with slate wagons with the traditional buffer and link coupling.